N option, I can change the slice size with the T option, or I can change my real-time priority with an R option, or I can determine whether I want timeshare or real-time round robin or real-time first in, first out. And that's the -S. And with top, again, a plus sign in front of it says that it's running as real-time. So, we do have the ability of restricting a CPU and making it private. The problem is this is only good at single process applications that have no children. So to maximize a process performance requires the CPU 100% of the time private, nobody else using it. So that implies the scheduler should not schedule any other processes to run on that processor and keep that process on the same CPU. Now to restrict this is an npadmin-R and then the number of the CPU, and an npadmin-S actually sets or shows me how things are set up. So let's see if I can do anything undo right now. So I am going to do an npadmin-S. And I see right now there are no restricted CPUs. So now I'm going to do an npadmin-R. I'm going to pick CPU 4. And now my npadmin-S shows that CPU 4 has now been restricted just for run-on. I'm going to exit, CD. So I have a binary here. It's the same as code 2, but I've changed the name on it so that I can spot the timing difference. And now if I do a run-on 4./code2 run-on, I'm now running dedicated on that CPU. And if I pop up top, a run machine, so there's the top code 2 run-on, and it is presently running on CPU 4. Now, run-ons have not been as strong as I have wanted them. With run-on, my code 2 should come out at 280 some seconds repeatedly. I'm going to see what it actually runs on, but since I've got all these other codes running, I am only 16% idle, so there should not be too much pressure on my process, but I'm saying it's not as strong as I'd like. So we'll see how that particular process runs. And again, I've run it 4 or 5 times, not just once. So with npadmin, I can restrict a CPU. That's what I just did. I can also turn a CPU off from system interrupts. So if there's one machine out there I know that runs batch on part of it and real-time on the other part of it. So they shut off interrupts on some of the real-time processors. I can make a CPU non-preemptive, which means turn off my clock interrupts to that particular CPU. Of course, most of these things depend upon multi-CPU systems. I can move the system clock to another CPU. CPU 0 is normally my system clock. And there's also something called the fast clock. The system clock is 1 second granularity, but when you get into real time, you need tighter clock time capability. They call that the fast clock. And it doesn't show the syntax here, but I can also direct VME interrupts to a particular CPU. Do you have a question? So in the process control market or something like that with data acquisition devices on VME buses, I can direct the interrupts to a particular CPU and make sure that the driver for it is locked down into that CPU. Most of this stuff is for the real-time market. So, to force the process to run on that same CPU, a run-on command, processor number, and whatever the command line arguments are. The trouble with run-on, though, is all children inherit affinity to that same CPU. There are applications out there that will fire off children to do things, and those children would then compete with me to get to the CPU. Also multi-threaded. If I spawn all these different threads, they all have affinity to my CPU. I would be competing with myself. So run-on is only good for single-threaded applications, and that's why pset was invented. Now pset's gone and instead is replaced with miser. Miser requires 6.5. I think there's probably only 15 to 20 sites out there actively using Miser. Go ahead.
UNL wants to use Miser, but he's had a lot of problems with it.
Yeah, the stability of Miser has not been good at all. And part of that is a new developer every 2 months on the product.
Is it getting better?
Well, there's trade-offs. Let's put it this way, the code is constantly being adjusted. Which means that there are new breaks that come in. Okay. Things have been getting better, but that doesn't mean that they've got everything caught. For example, mixing MP-admin and Miser is causing problems. Trying to mix all these different paradigms or all these different scheduling things at once is causing problems. So that's the disadvantage, to me, that's the disadvantage of Miser. I personally like the direction of Miser. One of my complaints for 15 years has been too many schedulers and none of them talk to each other. Miser at least guarantees me the CPU and the memory. Whereas with the other schedulers, I get the CPU, but now I'm waiting for memory, or now I'm waiting for I/O, now I'm waiting for network traffic. So what good is a CPU priority if you're bound waiting for one of the other resources? So I would really prefer schedulers to be able to schedule 6 resources: CPU, memory, disk, buffer cache, networks, and IPC, as well as minor resources like tape drives or CD towers or things like that. Okay, even NQE does not talk to NQS. And NQS talks to Miser, but Miser on one node doesn't talk to Miser on another node. So Miser doesn't work in a cluster. So NQE may talk to Miser on one node, and that node says, oh, I don't have any room to run you, but that Miser can't check with another Miser and say, oh, there's room in my reservation book, move it over. It's like going to the hotel. The hotel says, it's 2 in the morning, you're driving through the city, you stop at the hotel, they say, no rooms, and they'll call around for you to find a room for you. Miser doesn't have the ability to do that. Okay, so those are some of the disadvantages to Miser. So Miser is a user process, a user level process. It's running as a system daemon, but it shows up with PS. And it basically generates a non-conflicting schedule of jobs, what I call job packing. And I have to declare ahead of time the amount of time and memory space that I want, just like NQE required. So given the presentation of jobs to Miser, it searches through its reservation book and does a best fit. Miser runs as a system daemon. When I ask for Miser work, I make a system call to the kernel. I cannot talk to the Miser daemon directly because it's running as root. And they didn't do it as a named pipe, they probably should have. But instead they're doing it through a system call interface, which means I can bottleneck on that system call. So what happens is I make the system call, and then the kernel waits until my reservation time comes up, and then I come out of the system call with my Miser attributes. Disadvantage is if I go in and sitting there waiting for my reservation time and I take an interruption, I've lost everything. Okay, there's no real checkpoint restart working for Miser yet. Now it mentions a older web page here. That web page is obsolete. Just put a line through it. So this is my concept. Now this was a bad example. I took a 1-day interval. I said there's 86,400 seconds in a day. And I said, well, my code 2 takes about 300 seconds, 288. So let's set this quantum to 300 seconds. Then I took the day and said there's a total of 288 300-second quantums in a day.
Both of those lines say quantum.
We'll call it a quanta or quantum.
Okay.
Quanta is a single, quantum being plural. So yes, I do interchange them. So we took 86,400 divided by 300 and got 288 quantas, or quantum, in a day. What happens if I make the quantum too big? What's the disadvantage of that? And that's what I did here. I made it too big.
Waste time.
If I run over a quantum, for example, this is a 5-minute quantum, maybe I went 305 seconds instead of 300. that would result in 295 seconds of the next quantum that would be unschedulable. So even if I finish in the middle of a quanta, I cannot reassign the rest of the quanta. So I do not like quantas that get into the 300-second range. I recommend 20 or 30. Also, if I submit work to Miser, it can't schedule in the current quantum, it would have to schedule in the next quantum, which means it's going to be 5 minutes before I actually see it scheduled. Okay. So I don't like quantas to get too big. I think 20 or 30 seconds is the best to do. Even 1 minute I think is too big. So the default is 20, and sometimes people will go to 30. But then when I submit to Miser, it's going to take 30 seconds for Miser to talk back to me and say, here's the reservation that you've got. So in this example, I decided to do a prime, non-prime concept. So I said from midnight to 8 a.m. is going to be my non-prime, and from 8 a.m. to 5 p.m. I'm not going to assign anything to Miser, and then from 5 p.m. to midnight I'm going to give it back to Miser. So I got 3 segments in this configuration. Now what's wrong with this?
A job that runs in the first segment can't continue over to the third segment?
Correct. A job cannot span a segment. So what does that mean? Taking that one step further. During prime time, I submit a 7-hour, let's submit an 8-hour job. If I submit an 8-hour job, it won't even fit into this segment. It will fit into this one. So what I was thinking was prime time, but I wanted to go from 5 p.m. to 8 a.m. as a single segment. And this one does not do that. Okay. So if I'm trying to do a 5 p.m. to 8 a.m. job, this would be a bad example. Now here's another tough thing about Miser. If my segments are less than 24 hours, I start from midnight. If I'm over 24 hours, I start from midnight, January 1st, 1970, which is a Thursday night. So if I've got an interval that's more than 24 hours, I'm actually starting on Thursday night, midnight. And then I have to care about the weekend. So I've got a sample out here of an interval for Naval Research Labs, actually. That spans a week instead of a day. So the first segment, there were 11 segments in the week. The first segment is going from 0 to 1440, and these are 20-second quantums. So that's bringing me from midnight to 8 a.m. And then I'm going from 8 a.m. to 5 p.m. And then I'm going from 5 p.m. to 8 a.m. the next day. Okay. And the weekend actually is right here. So if anybody wants to play with a weekday, weekend schedule, I'll just send you a sample of this. So you basically have to figure out what's my quantum, and then I start at 0 and I go to wherever I want. In this case, I take 20 times 1440 to figure out how many seconds that is, and then convert that back into minutes or hours. And during that interval, I'm using 124 CPUs and 28 gig. The second one, they're all actually configured to be the same resource. I just can't change it during prime time, and again, cannot span any one of these segments. Now what happened at Ford was when they set up some of these, they put start times and end times, they put extra zeros in there, possibly the quantum too, and then when Miser started up, it had to spend days building a reservation book that was like 1 second samples for 10 years. And the Miser daemon just kept growing and growing, asking for more memory to hold this reservation book in memory. So that's why we put a limit of 2 months as a realistic limit for Miser work.
Had they intended
No.
to do 10 years?
No, they didn't. They just didn't go through the arithmetic, threw some zeros on there, and then asked why is Miser not starting right. So in this example, I had to figure out how many seconds to 8 a.m. and then that was 96 quanta. There's 108 quanta in this example and then 84 quanta in this example. So, just talking about miser now, I submit work to miser with the miser submit command. And NQE is doing the same command. NQE will use the miser submit command to talk to miser. It then talks to the miser daemon through a system call. The miser daemon goes to a reservation book and then figures out what my start time and end time is going to be and how much memory and how much CPU I need. And it then packs the jobs in. So it says job X will start here and end here, then job Y will start right after it. Now, in this example, even though we scheduled like this, maybe something was running here that was reserved and it finished early. So there was an opportunistic chance here for job X to run a little bit here and a little bit here, and basically running opportunistically before I actually hit my reservation time. That was like being at the bar. The disadvantage is that this process now is getting system cache thrash and the service times are going to be getting bigger and my billing is not going to be repeatable depending upon the load on the system. The second problem is that because this started early, it might end early and now the next process is going to start early, and after a couple of days everything has been shifted and is running opportunistically. And that's why they put a repack on there. So repack takes care of that. Instead of running it opportunistically, let's just move the reservation up and make it dedicated static. So they do plan, last I heard, of getting rid of opportunistic, which is a good thing in my mind. Because I want repeatable billing. So this is where we are. I want to configure and start running miser. First of all, you have to load EUESW miser. No license required, but the package has to be there for the user commands. No kernel change, no reboot required. Okay. But I have to load the commands. The second thing I have to do is figure out what my resource partitions are going to be. I got one site that is, for example, God1 and God2, and each of them have their own partition. Or Army, Navy, Marines. So this is one way to guarantee that if Army and Navy are each paying for a third of the machine, that they get a third of the machine if they ask for it. Now the disadvantage of miser though is if I ask for more than a third of the machine, I can't get it from miser. So people outside of miser can use things that miser's not using, but miser can't go beyond what it's asked for. In other words, let me put it this way as well. My bottleneck curve. So we had number of procs. We had elapsed time, for example. And as I'm running the system up, here was my number of CPUs. Here was my end proc. And we had a bottleneck curve that looked something like that, approximately. Now note that there is going to be system cache thrash effects in this area. What miser is doing is guaranteeing those CPUs. But I cannot have more use than I have capacity. So without miser, yes, I get system cache thrash, but I can oversubscribe my system. Miser cannot be oversubscribed. So I cannot configure miser to have more memory than I physically have. I cannot configure miser to have more CPUs than I physically have. Okay. So once I configure miser, I can't go past that configuration. Maybe it's a 16 CPU system and I say, you can only get 8 CPUs. So with miser, I could have run 500 of these things, but without miser, I could run 500 of these things, but with miser, I could only run 16 of them. So when you're carving up your partitions, they have to be less than the physical hardware that you have. And you want to figure out how many CPUs and how much memory. But if an interactive user wants that memory, it can take it as long as miser's not asking for it. But if miser comes in, it can preempt the interactive timeshare. So then I'm going to edit my miser.options and specify how much memory and how many CPUs I want, and they have to be less than I physically have. Then I've got to check config miser on. And I have to edit miser.conf. We're going to take a look at that file, which points to a partition configuration for each partition. Now there's always a system partition. And then there's an example of a default partition, but maybe I'm going to create Army, Navy, Marines. So in that example, system would be all the resources, and then I'd have miser_Army, miser_Navy, and miser_Marines. And the perm bits on the file, by the way, determine who can submit it. So I can do a group and chmod type of stuff so that only Army can submit to the Army partition. After I've configured that, then I start miser and check your syslog for error messages. It's not always very cleanly describing what things happen. For example, I can increase the buffer cache size, and miser tries to reserve too, and it says, can't, there's not enough memory. I experienced that in my last class. And then miser just dies and says, I don't have enough resources. So you got to check your syslog when you do it. This then is an example of my system configuration. So I have to declare my policy, what my quantum is going to be, and the number of segments that I'm going to have. So this is matching the example that I had a couple of slides ago. So during non-prime from 0 to 95, I've got 12 CPUs and 1 gig of memory. And then from 96 to 206, nothing for miser. And then from 207 to 288, again 12 CPUs and 1 gig of memory. Now you might want to make a note on this. This is bad, but they should map at the same number. This one ends at 95. The next one should start at 95. Or there's going to be one quanta, a 5-minute interval that's unschedulable. So the end, the start should match the prior end. So in your workbook, I would modify 96 and make it 95, and 207 should be 206.
So end really is how many quanta?
The end of the quanta. So 0 to 95, and then the other one is 95 to 206. What happened to me was I was doing it this way with the logic that you're going through right now, and set it up this way, and then when I looked at my reservation book, I had these breaks, every prime, non-prime. But it was a break because there was a 20-second quanta there that was not being reserved in the next quanta, or the next segment.
Okay, so that first segment actually runs from segment 0 through segment 94.
Or, depending on how you want to count 0 and 1, yeah. You had the question.
So your quantum 300, that says that each quantum element is 300 seconds.
Right.
So if it's a quantum 1, it'd be 1 second.
Right. And I think 1 is too small and 300 is too big. 20 and 30 are what I recommend. Again, that's the size of the reservation book, grid. So if I had 1 second, even a day would be 86,400 blocks within that day, and that'd build too big of a reservation book. Okay. And again, I have a prime, non-prime example that we can try loading here in a minute. So why don't I do that now? Let's get on to do, and I'm now going to go in and configure things and see what we've got. Before I do that, now gross view. Is going to show my memory reservations because miser presently has memory reserved. And again, even my virtual swap is still too big to handle it, but look at my memory reservation down in here. Most of my memory is already reserved by miser. We went through that and recognized that on Monday. So I'm going to shut down miser first. And that reservation is not released. The reason we don't want to release it is because I may want to restart it. And if I release it and somebody submits work, they could take the reservation, and when I try to restart miser, I can't restart it because somebody else took my reservation from me. So there is a second level, and I don't know what the workload is like or anything right now, but it looks okay. But there is a second level called cleanup. If I'm not using Miser, I need to run both. Now watch. Watch this up here. And there, my Miser reservation was now released. Now, if you submitted a couple of code 4s, you could steal that reservation from me and I cannot restart Miser again. And that's why it's done in 2 levels. So there's a stop and then there's a cleanup. And if I restart it now, I'm probably okay right now, but somebody could run a code 4 and then I can't restart Miser. And on my system now with the swap command, swap-s, I now see my reservations, instead of being 1.5 gig, are now down to 358 meg as a reservation. And I'm going to run pmem here. Now it's showing 741 virtual here and 170 physical. And we don't see Miser in there at all. Anyway, I'm going to go to ITSC config. Let me go to a larger window font. And if I cat miser.options, this is what's on the command line when I start up Miser. So I'm going to leave it where it is right now at 12 CPUs and 1.5 gig of memory. And I have a 16 CPU system with 2 gig of memory. So these have to be smaller than I physically have. Also remember, I would like to have my swap at least as big as my Miser memory. That way I can still run work. If Miser's not using it, I can still pack memory with non-Miser work. And as Miser comes along, everything that's non-Miser would get pushed out to my swap. So I'm going to leave that one where it is. The second one then was in the ITSC directory. And there is a miser.conf file first. And this one I'm going to change right now. And right now this system is configured with a system queue, a default, and a repack. I'm going to completely start from scratch. And I'm going to say, I'm just going to call it test. Oops. And again, if I wanted more than one, I could have test 1, test 2, or Army, Navy, whatever the partitions that I want to sub-break things into. So if I've got physics, chemistry, and astrophysics, I might create 3 partitions for each of them. Okay. So this simply points to the configuration files for each one. Now I'm going to edit miser.conf. Whoops, that wasn't the one I wanted. Before I do that, let me check my, I'm going to put that NRL example into place. Now one of the problems here is that the quanta has to be the same across all of them. I've got a 20-second quantum here. So I'm going to copy nrl.miser into ITSC, and I was calling it test.com or miser_test.com. So I'm going to check miser_system.com, and that one is still in 20. It's showing 1 total segment, and during all of that I've got 12 CPUs, 15 or 1.5 gig of memory. I'm starting at 0, and it looks like it's a 1-week interval here. So I'm going to pop up my calculator and take 3, 0, 1.40 times 20 seconds for each one of those gives me that number of seconds. I'm going to divide by 60 seconds to a minute and divide by 60 again to get to an hour. Divide by 24. I'm not sure if my arithmetic worked out right. I got 35. Let's work the other way. Okay. I have a 20-second quanta. So I want to know how many quantas are in a week. So they're taking this equation. So I'm going to reverse engineer it. Somebody may have changed the comments there. That's why I'm doing this. So 60 seconds times 60 minutes gives me 3,600 seconds to an hour times 24 hours, 86,400 seconds to a day, times 7 days, giving me 604,800 seconds in a week. I then divide by a 20-second quanta, and I do get the right answer. So when I did it the other way, I did some arithmetic wrong. So there's 30,240 20-second quantas in a week. And since my other configuration was for a week, I want the two to be symmetrical and match. Okay. So now miser_test.conf. Oops. I was in the wrong directory, right? So now going to this one, I've got 11 segments. Let's try a 20-minute quanta times 1,400. 20 times 1,440 gives me that number of seconds. Let's divide by 3,600. That gives me an 8-hour interval. Okay, so 0 to 1440 with a 20-second quanta is giving me 8 hours within that first segment. So that's from midnight to 8 a.m. Okay. Now rather than go through the arithmetic to break non-prime prime out, I already have the file there, so the next step is to see if we can start it. Check config miser on, it was already on, but I'm just confirming that. What else did we have here? So I've got the module loaded, I've done the partitions, I've checked the miser.options, did a check config miser on. I edited miser.conf and created a miser_test. And then check miser_system and it should match what the miser options are. And then I did a miser_test for my particular partition that I'm going to create. So now I'm going to start it. Before I start it, let me just do PSEF and grep for miser. Oops. And it's not running yet. And as I started, oops, let's look at gross view again. There's my memory reservation. So when I restart it, resources are exhausted. I'm unable to start it. So we got a little bit of a problem here. And I know what it is. miser_test.conf. When I set it up, I asked for 28 gig and 124 CPUs. Okay, so I'm going to substitute 12. I got this whole thing. Oops. And then the 28 gig. By the way, I'll common make the mistake of putting a B on there.
What is it?
Doesn't take it.
What is it? /28/1500M/G, isn't it? Now do global search and replace.
Sure, but I don't like globals because I never know what I probably did.
20 G for a second.
So let me try starting it again now. Before I do that, by the way, PSEF, rep, miser, it's not there. I'm also going to tail var, ADM, syslog, and there was an error there. So we see starting miser 12 meg 1 gig, but then it tried to create the Q test and that exhausted the resources. So now I'm going to try it again. It's the init.d, miser, start. And this time it successfully started, and I also see my memory reservation go up, and swap-s now shows I've got 1.7 gig reserved on the system. Okay. It's the init.d, miser, stop. It's the init.d, miser, clean up. And this time I just wanted to check my permissions, ls-l on miser underscore test. So it did not have execute permission on that particular partition. I'm just going to chmod it. And then restart miser this time. Now I can get out, and at this point I'm ready to start with miser. So I've now configured it. If I look at the workbook now, we've gone through those steps and successfully got it started. We used a prime non-prime concept, and that's what I'm going to look at now. So with miser underscore capital Q, I now see that I've got one partition named test. Miser underscore Q info little q on test now shows me what my reservation book looks like. And I'm going from today at 16:19 to next week at 16:19. Now I'm not sure whether this is a bug or not, but note that my memory has been rounded down to 1 gig, whereas I started and reserved 1.5 gig. And this is 10.0 or 6.5.10, so that is still existing. So I don't know why that's showing up that way. But we saw the reservation was 1.5 gig. Okay. Now I want to submit work. Now in this example, here's where I made the mistake. Remember when I started the next quanta, one after? Then I actually got breaks here, 20, 40, and then I can actually see a 20-second gap here. And that was because I didn't match the start and the end between the segments. Okay. So to run the work now, I do a miser submit, the name of the partition, and then my resources required, and then the name of the program. Now I like to put it in the background, and then I am able to actually get a miser output report. This is an older output report. And in this example, I happen to do a PS-C, which shows me my class, and code 2 miser in this example started off as a B, and then a little bit later I did a PS-C, and I see that code 2 miser went critical, BC. It went critical at this 1613 timestamp. Now I should have had a date in here to actually see it change. But if I submitted it early, it'll start off as a B. When 1613 comes along, it will go to BC. Also, when I fired off the batch ID, I can do a JInfo on that batch ID and get that same report again. So, miser underscore submit. I've already got a binary -Q test -O T equals, I'm going to go with 300 seconds, C equals 1, and M equals, I'm going to go with 40 megabytes. Oops, I think it's an M, not an MB. We'll find out.
What if you don't put an M in there?
Then it's 40 bytes.
40 bytes?
Yeah,
No, I mean, what if you don't even put an M at all in there?
that's 40 bytes.
No, I'm saying the whole thing, M equals 40, that's how much memory, right?
Right. Let's try it without anything.
What's the C mean?
Number of CPUs. Let's just see what it does. Memory not specified, so it ignored it, no default. I was also asking for a default on the cubes, because I didn't have to specify that all the time. I don't think they've done that either. Let's just try it. Yeah. So the Q was a required argument. So now let me try putting it together again. And I'm going to put it in the background this time so that I can still use my window. So now I've submitted it, and Miser is now assigned it a job ID. And now I actually see, and this was a different report than what we saw in the workbook. It's actually 1623:20. Let me do a date command. It's past that interval right now. So what I'm doing is I'm just going to fire off a bunch of these now and start filling up my reservation book. And this is where you start getting into problems with Miser. All these reports are coming through a system call, which is a very poor way to deliver data. Miser QInfo capital A will now print out everything. So here's all the codes that I'm running. And let me do a ps-c grep for code. And I see that all these codes are running batch critical. If I do a date, 1624, they all started right after 1623 or 1624. What I'm trying to do is actually load it up enough. Okay, there's some that are going to come in at 1628. So if I do a date, I'm in 1624, miser underscore QInfo dash A. I now have a couple that are going to run at 1625. This particular one is going to go critical at 1625. Now if I bring up top, I can now see the ones that were scheduled as batch critical, but there are some that are running opportunistically. So I can take that process group ID, which also is the batch ID, and find out when is that thing going to go critical. So I can do a miser QInfo on it and then actually get the time that I expect to see that thing go critical. Now, miser underscore QInfo dash, you had a question? So the one I was going to look for that was going to go critical real soon, see if we can catch it here, 1625:46. This one at 1628. So this process here is running as batch. Okay, and it is accumulating time node, so it is actively running. And we've got 2 minutes before it's going to go batch critical. We got another minute and a half. Meanwhile, by the way, remember with MP-admin, I still have a CPU restricted. Recently somebody had problems where they had a restricted CPU and Miser would not start. So there are problems or competition between the MP-admin and the Miser interface, and this is more of that stability issue. The code's constantly changing. In fact, when they tried it, even though 0 was not the restricted CPU, the error message from Miser was CPU 0 was restricted. And it wasn't 0, it was just the code wasn't smart enough to figure out which CPU it actually was. So depending upon your release, this stuff changes all over the place, but you generally do not want to have restricted CPUs on a Miser system. Now this system seems to be handling it okay.
Yeah, because your run's not using that CPU. It's sitting there being idle.
Because it's been restricted. Okay, here we come. Assuming I picked the right one.
Another second.
There we go. 4 more seconds here. I would have expected it by now. I must have the wrong one. Miser underscore Q info dash A 16045. Oh, 40 seconds after.
So about now, or you're getting close to it.
Oops, it got killed. I ran out of CPU time. I was thrashing. Okay, so I never even got to my reservation time. And that's not a good thing to have happen. You're not supposed to have time consumed in opportunistic batch charged against you. This release is doing it. My other codes, by the way, are starting to give me some output. But my point was that thing should not have killed. Of course, I don't know which one it actually was, but I've got several that have died now. Let me do an ACPI-B-N code 2 MIS agent. So they were dying right here, right at about 300 seconds. It varies a little bit, probably due to system time. And let me do that again with the -F option. So with the F option, I can see a status 11, which is my signal number. But they all died right around 300 seconds. So I still have 4. It looks like those just finished now. So I've got 4 still running. Now, I don't like running opportunistic. In fact, these things are all dying. Let's tail, for example, var ADM syslog. People using Miser do need to check syslog. And it says it's killing the jobs because CPU time ran out. So they should not have been charged for opportunistic CPU time. Down to 1 process now. ACPI-B-N. Now, instead of doing it that way, I'm going to do it static. Oops, history isn't there. So this time I'm going to try miser underscore Q or miser underscore submit dash Q test dash O C equals 1. T equals, I could have gone 300, I'm going to go 320 this time, just to get a little bit more breathing room. M equals 100 meg. I don't need 100 meg, but I'm just using that to fill up 1 gig quicker. But what's missing now is static. Static says, don't hang out at the bar, go straight to your table. And this is the only way to guarantee you don't have system cache thrash. Remember yesterday morning when I showed you the miser chart, the Perfex data was all flat? That was run statically. These processes that were timing out probably thrashed so much that they were exceeding their approximate 290 seconds, which we knew the program could do. By the way, I never did see this, but ACPI-N code 2 run on. that isn't very good either. It still came out at 309 seconds. So it still did have some thrashing going on with it. It's not supposed to do that. So where was I? I was going to submit this one now. /code2 MIS. Put it in the background. So static says don't let the thing thrash. And meanwhile, these things are going to sit there in a PSEF, correct for miser. They will sit in a miser submit state until they are actually accepted by miser. So we're starting to get some jobs that have been submitted by miser and they're asking for SK static. So now if I bring up top, the only thing I have is batch critical. And what I'm hoping to see now is that these programs should come out at 288, 290 seconds. That's where these programs should be. So I already had one killed. Well, that wasn't a static one, that was a non-static one. Now, let me go back to the workbook for a second. We're going to talk about CPU sets in a second here. But we can also use NQE for miser. So this is the next step. I've got to load and configure miser, which we've done. You have to install NQE 3.3. This is the URL where you can find NQE downloads. So that's what I need to do now is queue manager set job scheduling miser normal. So while we're waiting for those jobs to finish, we're going to do a qstat-8 or qstat.
Actually, that won't fly anymore, cray.com.
There's still a cray.com, isn't there? For cray. But yeah, I know what you're saying. I'm going to check to see where a new download location is. But that's the typical download location. There are inst images for it as well, but anyway. So I'm going to do a queue manager. Oh, wait a second. CD NQS_config. So I've got an NQS configuration, and I'm going to create a queue called lab. Let's change it to test. So I have to create a queue, and then here, instead of setting job scheduling normal, I have to set it to miser. Okay, so the syntax was set job scheduling miser normal. And the next thing I have to do is associate the queue to the miser partition. So I have to do a set miser, NQS queue name, miser partition name, and a scheduling window that says how far into the future do I want to look into the reservation book. Okay, so the scheduling window says look into the next hour. If I didn't have that, or I could specify look into the next week, I could have stuff queued up and scheduled next week. And you may not want to do that because eventually your process day would fill up with all these miser submits. So you don't want too big of a scheduling window. So I'm going to do a set miser. Test was the NQS name. Test was also the miser partition name. And I'm going to go with 3600 for seconds. And now I'm going to do a queue manager and feed in that new configuration file. And see if everything works. qstat. I've now changed my configuration. I've now created a small, medium, large, huge concept. And I've also got this test queue, which is the one that we're working on now. So based upon my job limits now, different jobs are going to end up in different queues, and that way I don't have to sit with a 30-second job waiting for code 2 taking 3,000 seconds or something like that. So now I'm going to test it. In your home directories, in that real WL directory, there was a miser job sample. Go to miser.mqs. And in there, I have to change my queue name from lab to test. So the two things I need is a -x option to say I'm talking to miser, and then this is all the stuff that I needed to declare, including the static. And then the queue name would be test. So Warren, if you're following this, your home directory has a code2 miser.nqs.
Yeah.
Change the queue name in there from lab to test, and then try submitting it. By the way, a bunch of those that were static have now finished. I'm just cleaning up my directory. So I'm going to try it. First of all, qstat, no jobs running. Qstat-A, no jobs running. So I'm going to do a qsub code2 miser.nqs. Oops, no such qlab. I guess I didn't change something. Code2 miser.nqs. So now I'm going to load up miser again, but through the NQS interface. Now before that starts, I want to go back here. Now that those other jobs have finished, I want to look at code2 miser and see what they look like.
You want to unrestrict 4 or leave it?
I'm leaving it restricted right now, but it would probably help. And it is not helping me. The static is not helping me. I should be coming in, some of these are still coming in quite a ways away. Where am I in date? 39. So these are the ones that I ran static. And they are still coming in over 300 seconds. So I'm not happy about this. It should have been right down at 288 repeatedly, predictably. This is where they're changing the scheduler all the time. So they are still thrashing more than they should. They're not getting the affinity that they should. Now what's happening in development is a lot of people are focusing on CPU sets rather than miser. So there's been a lot more effort to get CPU sets stronger, which is weakening run-on and miser affinity. But those should not have come in over 300 seconds. They should have repeatedly come in at 288. If I was on a 658 system, they would have come in repeatedly. I don't remember 659 because I had other problems last class, but here it's definitely slipping. The only way I can confirm that is to run each of these with perfx and look at the perfx counters. So, MP-admin, I'm going to do what was suggested by Warren and do a remove. MP-admin -U will unrestrict it to schedule unrestricted. R was the one that I did to restrict it. So MP-admin -U 3 MP-admin -S. Whoops, it was 4 that I unrestricted. Now it's no longer restricted. Let me see how those jobs are doing. Qstat-A. By the way, with those miser jobs now, ooh, bad. I see R01. Not very good. Is anything running? Yeah, they are running. Batch critical. But I can't tell what terminal they're on. So that should be mine. all of them were through NQS. So I'm not sure QStat-A, NQS is showing them as an R01, and that is bad.
What is it, ours?
That's the number of processes to the job. And let's do something here, man, JStat. We can display information about all jobs on a job ID, limit information, or about each process. So if I do a QStat-A, here's my job ID. So a JStat-J on that job ID, -P. So it's only showing SH within the job. And for some reason, the actual process running under Miser is not showing up as being known by NQE. That's what I'm seeing. Let me do a JStat-A.